Good morning to everyone. Today I would like to explain hybridization concept. See here how to calculate the type of hybridization of a central atom in a molecular ion. Hybridization takes place in central atom of a molecular ion. So many different type of hybridizations are there. SP, SP2, SP3 like that. By using simple tricks to calculate the type of hybridization which are present in a molecular ionic species. Okay, see. Trick number one. Trick number one. See here, by using number of sigma bonds. What? By using a number of sigma bonds, we are going to calculate the type of hybridization which is present in a molecule of a central atom. Okay, see. Number of sigma bonds and here type of hybridization. Type of hybridization. See, for example, two sigma bonds are formed in that particular molecule. Then the hybridization of the molecule, the hybridization of that particular central atom is nothing but sp hybridization. If three sigma bonds are formed, then sp2 hybridization. If four sigma bonds are formed, the hybridization of the central atom is sp3, like that. See here. If two sigma bonds are formed, then type of hybridization is nothing but sp hybridization. If three sigma bonds are formed, sp2 hybridization. Four sigma bonds are formed, sp3 hybridization. Five sigma bonds, sp3 dehybridization. Okay, sp3 dehybridization. If six sigma bonds are formed, six sigma bonds are formed, then hybridization is sp3d2 hybridization. If seven sigma bonds are formed, sp3d3 is the hybridization. So बहुत simple सा trick है. So very easy trick to learn or calculate or find out the hybridization of the central atom in a molecule. If two sigma bonds, that is nothing but covalent bonds, are formed, then type of hybridization is sp. Then shape of the molecule is linear and bond angle is 180 degrees. Like that. See. I am going to take few examples to explain the sp, sp2, sp3 like that, all hybridizations. See. Two sigma bonds, sp hybridization. Example BeCl2 comma BeF2 molecules. See, in In beryllium is a central atom. Beryllium belongs to second group element. So it is having two valency electrons. One is bond with chlorine, another one is bond with chlorine. So two sigma bond. This is one sigma bond. This second one sigma bond. If two sigma bonds are present, then hybridization is sp. Hybridization is sp. If in case of BeF2, here also same, beryllium form two sigma bonds, then hybridization is nothing but sp. Number of sigma bond decide the type of hybridization in a central atom of a molecule. If two sigma bonds are present, then type of hybridization is sp. Example, this. Next, three sigma bonds are present. Three sigma bonds are present, then hybridization is sp2. Hybridization, the best example is nothing but BCl3 molecule. BCl3 molecule. In BCl3 molecule, boron is the central atom which is having three valency electrons. Boron belongs to third group or third A group or 13th group. Boron is having three valency electrons, bond with chlorine, chlorine, chlorine. See, how many sigma bonds are formed here? Three sigma bonds. The first sigma bond, second one, third one, three sigma bonds. So three sigma bonds means hybridization is sp2 hybridization. One is like that, simply spp. You can write like this also, sp2 hybridization. In case of four sigma bonds, sp3 hybridization. Example, CH4. Carbon central atom. Carbon is the central atom which undergo sp3 hybridization. Carbon belongs to 14th group, which is nothing but 14th group element. So it is having total 4 valency electrons. 1, 2, 3, 4 valency electrons. One is bond with hydrogen, second one bond with hydrogen, third one, fourth one. So total number of sigma bonds present here are nothing but 4. Sigma, 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 sigma. We can assume this one is a sp3 hybridization. sp3 hybridization. Next one, if 5 sigma bonds are present, then hybridization is sp3d hybridization. I am taking one example, that is nothing but PCl5. Phosphorus is the central atom which undergo sp3d hybridization. Phosphorus, that particular element belongs to 15th group or 5th A group element. So 5th A group element means it is having total 5 valency electrons. How many? 5 valency electrons. 1, 2, 3, 4, 5 valency electron. One is bond with chlorine, second one chlorine, third, fourth, fifth. So how many sigma bonds or solid bonds are formed here? Total 5. How many? Total 5. You can assume this particular bond is as a S, P, P after B, D. sp3d hybridization. Why? Because S means only one orbital is present. S, px, py, pz, like that, sp3, and after p, d orbital. So sp3d hybridization. sp3d hybridization. So this is very easy or simple trick to find out or calculate the hybridization. If two sigma bonds are formed, sp, three sigma bonds are formed, sp2, four sigma bonds are formed, sp3, if 5 sigma bonds are formed, sp3d, 6 sp3d2, 7 sp3d3. Now I am going to show that if 6 sigma bonds are formed present in a molecule, 6 sigma bonds present, then hybridization is sp3d2 hybridization. 6 sigma bonds are formed, sp3d2 hybridization. The best example for this is nothing but SF6 molecule. SF6 molecule. In that, sulfur is the central atom which undergo sp3d2 hybridization. Sulfur belongs to 16th group. So it is having total 6 valency electrons. Sulfur is having 1, 2, 3, 4, 5, 6 valency electrons. 6 valency electrons are bonded with 6 fluorines to form 6 sigma bonds. 1, 2, 3, 4, 5, 6 sigma bonds. So hybridization is nothing but S, P, 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 D, D. sp3 d2 hybridization. If 7 valency electrons are present and 7 valency electrons are bonded with 7 atoms, then it forms sp3 d3 hybridization. The best example for sp3 d3 hybridization is nothing but IF7. IF7. 7 sigma bonds, sp3 d3 hybridization. 7 sigma bonds, sp3 d3 hybridization. The best example is nothing but IF7. Iodine. Iodine is the central atom. Iodine belongs to 17th group element, that is nothing but halogen family. So it is having 7 valence electrons, 1, 2, 3, 4, 5, 6, 7 valence electrons. 7 valence electrons are bonded with 7 fluorines. Total 7 sigma bonds are formed here. See. 7 sigma bonds, 1, 2, 3, 4, 5, 6, 7. 7 sigma bonds, then type of hybridization is nothing but S, P, 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 D, D, D. sp3, D3 hybridization. Simply assume that one bond is nothing but S orbital, one bond is nothing but P orbital, like that. Total number of bonds, if two bonds are present, then one is S, one is P. If 3 bonds are there, one is S, other 2 bonds are P2, sp2, like that. sp3, sp3d, d2, d3. Okay, and next one. This particular trick is not enough to calculate the total number of different molecules which are present. Okay. So another trick also there to find out or calculate the hybridization of a central atom in a lone pair containing molecules and in ions. That is nothing but second trick. I hope this particular trick is very much useful to calculate the hybridization. So this is very simple way to learn the hybridization. This is going to be useful in your examination point of view, especially NEET or JEE competitive examination point of view. Trick number 2. Number of sigma bonds plus lone pairs. It gives hybridization. Number of sigma bonds plus lone pairs. It gives hybridization in case of non-bonded electrons are present in a molecule or lone pair of electrons which are present in a molecule. See. So, number of sigma bonds plus number of lone pairs, it gives to type of hybridization. See here, I am taking 3 sigma bonds, 1 lone pair of electrons. So total is nothing but 4, means sp3 hybridization. 3 sigma bonds, 1 lone pair of electrons. Total number is nothing but 3 plus 1. Total number 4. 4 is nothing but sp3 hybridization. Example, NH3 molecule. See here, nitrogen is having 5 valency electrons. In NH3 molecule, that is nothing but ammonia. In that, nitrogen is the central atom. Nitrogen atom belongs to 5th group or 15th group or 5th A group. So it is having total 5 valency electrons. In that, 3 valency electrons are bonded with 3 hydrogens. And non-bonded electrons are 1 lone pair of electrons are present. See here, first one bond with hydrogen, second one bond with hydrogen, third one bond with hydrogen. 1 lone pair of electrons. This is nothing but 1 lone pair of electrons. See here, 1, 2, 3 plus 1, 4. 3 plus 1, 4. 4 means what? sp3 hybridization. So, you can simply assume that first bond is nothing but S, second one is nothing but P, third one is nothing but P. A lone pair of electrons are nothing but P. So, here sp3 hybridization. NH3 molecule hybridization is sp3. 3 bond pairs are 3 sigma bonds plus 1 lone pair of electrons. So total number of bonds, total number is nothing but 4. 4 means sp3 hybridization. So in ammonia molecule, nitrogen hybridization is sp3. I am going to take another example. Total number of bonds, sigma bonds are nothing but 2 and total number of lone pairs are nothing but 2. So 2 plus 2 is nothing but 4. So it gives sp3 hybridization. It gives what? sp3 hybridization. See here. Example, H2O molecule. Example, H2O molecule. See, in H2O molecule, oxygen is a central atom. Central atom, oxygen is having 1, 2, 3, 4, 5, 6. How many valency electrons are present? 6 valency electrons are present. Why? Because oxygen, that particular atom belongs to 16th group or 6th A group. So 6 valency electrons are present in oxygen. Out of 6 valency electrons, 2 are bond with 2 hydrogens. So how many sigma bonds? 2. And 2 are, this is 1 and this one is 1. These 2 are nothing but what? Lone pair and lone pair. So total number of sigma bonds 2. Total number of lone pairs 2. 2 plus 2 means what? 4. 4 means what? S P P P sp3 hybridization. sp3 hybridization. So like that, these two simple tricks. So one trick, that is first trick is very simple. Okay, that particular trick is very much useful when that particular molecule is not having any lone pairs. So simple, by taking number of bond pairs or sigma bonds, you can easily calculate the hybridization, the type of hybridization of the central atom in a molecule. If in that particular molecule, if lone pair of electrons are present, then in that condition we use trick number 2. So number of sigma bonds plus lone pairs. Okay, one lone pair means 1, 2 lone pair means 2, like that. See, I am going to give another 2 examples for by using this particular trick number 2. Xenon F2, Xenon F4, Xenon F6. See, Xenon is a central atom which is having 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. In the 2 valence electrons are bond with 2 fluorines. Okay, next. 1 lone pair, 2 lone pairs, 3 lone pairs. So it is having 2 sigma bonds plus 3 lone pairs, total 5 is nothing but sp3d hybridization. This is sp3d. Okay, if a molecule in that central atom containing 8 valency electrons, in that 2 are sigma bonds, 3 are lone pairs. So 2 plus 3 total 5 means sp3d hybridization. sp3d hybridization. In case of xenon X4, xenon S4, xenon tetrafluoride, xenon is a central atom. 1, 2, 3, 4, 5, 6, 7, 8 valency electrons are there. In that 8 valency electron, one is bond with fluorine, second one, third one, fourth one. So 4 valency electrons bond with 4 fluorines to form what? 4 sigma bonds. So here number of sigma bonds, how many? 4 plus number of lone pairs are nothing but what? 2. 6. sp3d2. Hybridization is sp3d2. Total 6. sp3d2. sp3d2. Total 6. How many? 4 bond pairs, nothing but 4 sigma bonds, and 2 lone pairs. So 4 plus 2 is nothing but 6. So hybridization of the molecule is sp3d2, xenon tetrafluoride. Now xenon F6, simple one. Xenon is a central atom. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Out of 8 valence electrons, 6 are bound with 6 fluorines. Lone pair of electrons. See, 6 bond pairs plus 1 lone pair, total 7 sp3d3. S P P P D D D. sp3d3 hybridization, very simple and easy to understand the type of hybridization. sp3d D3. sp3d3. Okay, so xenon F2 molecule hybridization sp3d, sp3d2, and xenon F6 sp3d3 hybridization. So trick number 1 is very simple. Okay, that trick is useful to calculate the hybridization of a central atom which is not having lone pair of electrons. Second trick is useful to calculate the hybridization which is having both sigma bonds and lone pair of electrons. Okay, I think and I hope this particular video is very much useful for you people. Thank you very much.